أنا اسمي دارين مصطفى، عندي 16 سنة، ساكنة في القاهرة، بدرس في ستيم إسماعيلية وداخلة جريد 11 إن شاء الله.
هاي، أنا نورسين أسامة، عايشة في دمياط، بدرس في ستيم إسماعيلية وداخلة جريد 11 إن شاء الله.
So our idea's name is nitrous oxide decomposer, and we aim to solve the problem of climate change, as I'll discuss more. Climate change is a change in the statistical distribution of weather patterns when that change lasts for an extended period of time. Climate change may refer to a change in average weather conditions or in the time variation of weather around longer-term average conditions. So one of the major causes of this problem is increasing the rate of greenhouse gases, which one of them is nitrous oxide. Nitrous oxide is a potent greenhouse gas that remains in the atmosphere for about 121 years. It's also a global warming potential 298 times greater than that of carbon dioxide over a 100-year time frame. So nitrous oxide is also an important ozone depleting substance that thins the ozone layer that's responsible for protecting our Earth's planet from ultraviolet radiation. So simply we will make a reaction or a decomposition reaction that involves nitrous oxide to produce oxygen gas and nitrogen gas. So I'll discuss more about the reaction. To avoid the incomplete conversion of N2O into NOx species, the reaction is usually carried out in fixed bed reactors over an inert packaging material to maintain constant temperatures. In order to improve the selectivity and lower the activation energy of the reaction, the catalytic decomposition of nitrous oxide has been intensively studied on various metal and metal oxide catalysts as well as zeolites. In general, the catalytic reaction requires the absorption of NO2 on an active center on the catalyst surface, which is followed by the dissociation of the molecule into gases, nitrogen and oxygen atom absorbed on the catalyst surface, as I said before. So molecular oxygen is then formed by recombination with another absorbed oxygen atom or by the direct reaction with another N2O molecule. The two reaction pathways for the decomposition of NO2, while thermic catalyst decomposition of N2O still requires elevated temperatures and is mostly restricted to processes like waste gas treatment in industry or combustion engines. Photocatalytic decomposition can be applied to reduce the N2O emission of other sources at room temperatures or even below. The irradiation of photocatalysts with light in the UV range excites electrons from the valence band into the condition band of a semiconductor if the energy of the inside photons is larger than the band gap. The excited electrons can reduce absorbed nitrous oxide to N2 and an oxygen atom absorbed on the surface of the catalyst. After that, we can use the nitrogen in making fire extinguishers. Also, it's from the best gases that enter in making this substance. We can make a reaction between nitrogen and oxygen to form ammonia, like N2 plus H2O equals NH3. So it was simply our reaction that we will take nitrous oxide from factories chimneys or cars engines, and we will make a decomposition reaction to produce oxygen gas and nitrogen gas. So we will solve the problem of climate change. Also we will solve the problem of pollution of air.